So now we are going to add some parameters. So we have to do this in two places. So the first place we have to do it is under this thing called New Project Audio Processor. And we actually, before we do that, we actually have to create audio parameters. So we're gonna create them here. So you have to use something called a namespace JUCE. This will throw everyone off because it doesn't tell you explicitly that you have to do that, only if you're a big C++ person. So we're gonna call it frequency parameter. All right, so it doesn't like that. Why? It does. Okay. And so this JUCE : so JUCE is the name, a namespace. So you put things in namespaces to have collections of functions or classes, and then that way if there's another library that might have audio parameter float, you know that you're using the JUCE one and not the Apple JUCE one. All right, so we're going to do the same thing. Float, and the star means pointer, which just means an address in memory. And you don't use these in Java, but we do in C++ all the time. So it's a way of allocating memory. All right, so JUCE, we have the frequency parameter and amplitude parameter. So we're going to use those to change our input and output, mainly just to change our frequency and our amplitude. So let's, now we have to add the parameters to the stack here. So there's a function called addParameter, and it takes basically the instantiation of your parameter. So we're going to do frequency parameter equals new JUCE audio parameter float. And then we give it a name, which is used internally. Then we give it an ID, and then we give it a name. Both of these are used externally, but you could eventually use them to print those to the screen. And then we give it the value range. So this is the minimum value, the maximum value. So this is our frequency, so we'll give it 1500. And then default value. And that's good. So now that is something that exists. So now we're just going to switch this over to the amplitude. And amplitude should be between 0 and 1. And we'll do 0.5 is our default. And why don't you like that? Because it's undefined. No, because I spelled it wrong here. I spelled it correctly here. Fix it. Okay. Excellent. Okay, so now that we set those up, we just need to access them in our process block that we set up here. And since we used getters and setters, we're going to put those here. So we're going to do pd.set frequency, and then you're going to do star m frequency parameter, and then you're going to do pd.setAmp star m amplitude parameter. Okay, and the star means it's actually dereferencing the pointer, which means it's getting the value that's at the address. So it's basically, this is just a number. But it's, if you're not a C++ person, it's super confusing. So don't worry about it. So now we have to actually change the values. So we're going to need to go to the plugin editor and make some knobs. And it's pretty easy to make a knob in JUCE. We're just going to do JUCE slider, call it M frequency. And the M on all these is kind of a convention that a lot of programmers use to say that it's something that belongs to the unit, to the plugin. I don't know. You can use whatever you like. Basically, I think it's associated with a parameter, but there's probably a better explanation for that. Okay, so now this is where you're going to probably not want to look directly at the screen. All right, so we're going to find underneath where it says set size, which is the size of your window. This is going to look a little bit like processing. So we need to do all this first. Okay, so the first thing we need to do is set something to get the parameters from the stack. Get parameters. All right, so it's going to get all the parameters, and then we are going to create a new audio parameter float. And this is now local to our editor, not to our processor. And what we're going to do is get the parameter and cast it to an audio parameter float. Pointer. So params.get unchecked. Okay, I told you not to look directly at the code. You're going to be blinded. Okay, so what the heck is going on here? All right, so this stores all of our parameters that we created in the processor. Okay, actually it's the stuff that's instantiated up here. So when you do add parameter, that goes into this class or something. It is, we'd have to look at it exactly. It looks like some sort of array. Yeah, so it's an array of parameters. And it basically goes in the order that you put them in here. So 0 is the first one that you created. And so that was also called frequency parameter. So that's good. We're going to keep it consistent. We cast that, which I don't know, it's probably just like a float, but we cast it into this float variable, add audio parameter float. And the function get unchecked, right? It's a member of this class. Okay, so now we have our sliders called M frequency and M amplitude. Probably should just call them, frequency slider and amplitude slider, but this is kind of how programmers like to program. All right, so we're gonna basically do, I am just gonna copy and paste some code and talk through it, so you don't have to watch me type. Okay, so the first line is you're going to set the bounds of the box that this knob or slider, it's called a slider, it's more like a knob. You're setting the bounds, right? So it's basically the X and Y, and then it's width and height. So this is not too unfamiliar if you've done any sort of 2D objects in processing, right? It's like a rectangle. You tell it where it's supposed to go and its width and its height, and it'll draw it for you. Select the slider style, and this is where we're basically telling it to be a knob, or what's called a rotary vertical drag. And it's the worst. This is what gets really confusing about C++, is it's got a namespace which has a member called slider, which has a member called slider style, which has a member called rotary vertical drag. Okay, fine. that's how they want to do it. So you just have to type in juice, : slider, slider style, rotary vertical drag. Okay, and you could look up set slider style if you wanted to try different styles, but that's just how they want you to do it. Right now we just set it to no text box. That's what this means. So again, you have to go into the member all the way down to no text box, which is just, these are just enums. These are just enumerated lists that have numbers. So it just is a number. If you knew the number, you could put it in there directly. So that's number 6 and that's number 0. And then you're just basically saying text box style is read only, which is true, and then width and height. So we're just saying 0, 0 because we don't want a text box right now. But try a text box if you want one, and then you can put stuff in the text box. You're going to set the range, which is going to be basically and this is why you use the audio parameter float. Gosh, what is that? Whatever variable, because it has a member called range start and range end. So you don't, if you change the range over here, if you change the range here, you don't have to go back to your editor and change it again. So it just gets it from the parameter that you created by calling it that value here. So it's nice little, like, get everything from the processor into the editor. Okay, and then set value, it's going to just be the value of the M frequency parameter, which will be the default value. And then add and make visible M frequency. So this is basically saying draw it to the screen. And what are we drawing to the screen? The slider called M frequency. I suppose maybe you don't want to make it visible. Cannot think of a reason why this wouldn't be default, but apparently it is. And then you have some behaviors that we add. Not in the UK, sorry. All right, so the sliders have behaviors. So the sliders on value change, right? This is basically a way of getting away with making a function inside of when you're setting a value to something. So it's called a lambda function, and don't want to get into that because that's like another layer of C++ that you don't need to know. So if you kind of just copy this style, which is put in brackets this and then your parameter, it's going to create a lambda function, which basically is then saying get the value of the knob or of the slider and put it into the frequency parameter, right? And then that will go to our processor and update our number, right? So we have to get our number from the GUI, then give it to the processor, which then goes to our algorithm, and then that changes our sound. Okay, and then we just want to make sure that we have on drag start and on drag end also set, which is going to be this thing called begin change gesture, which is a member of M frequency parameter, and end change gesture. And these are all this stuff is kind of like standard JUCE stuff that you would use on a lot of different types of graphical user options. So you'll see if you wanted to get more into JUCE, these would become very familiar. But this little arrow here, it just means it's like a dot in C++. But because it's we're dealing with a pointer, you have to it's a dereferencing of the function. So the dot won't work, but you have to use the arrow. So we do the exact same thing with the amplitude, and we just change M frequency to M amplitude. So we change the parameter name, M amplitude parameter, that we're going to use to get our values and store them in. And it's the second value, right? Because we added it second here. So it's the second value. And we do almost the same thing, except that we add 100 here because the X, we want it to not be on top of the other one. We want it to be 100 over, so it's right next to it, or wherever you want it. It could be 100 down, depending on your style. And everything else is exactly the same that we did before. So nothing has changed. So that's why copy and paste this stuff and just change the values And if you forget one, it will tell you that you screwed up, or you'll hear it and screwed up. Okay, and that should be everything we need to run the plugin. And there you go. Congratulations, you just made a test tone. So all now you have to do is just keep updating the parts that you want to change. So you could update your run algorithm and then to something more complicated, and then you could just keep using the same knobs, or you can add more parameters and add more knobs and do new things. So to get deeper into JUCE, just go to juice.com, and there's a lot of resources out there. And so hopefully the idea is that you could go from processing using Pd4P3, and copy and paste most of your code into this PD algorithm here, and then use the same template model down here, with just adding your own getters and setters, but basically just run the algorithm and set the samples here. And no matter what you do, when you change the algorithm, everything else will change. And then you just have to then keep track of your parameters and your knobs and all of your GUI stuff, which is more of a JUCE side of things. But you could test the algorithm in Pd4P3 in processing and really make sure it's robust and do a lot of experimentation. And then when you're ready to put it into a plugin, then you could use this tutorial to get started and just reuse the code with a few modifications like you saw in the video. So I hope that's helpful. And if it's not, well, just use JUCE. That's why it's there. It's got plenty of stuff for you to make plugins with. But hopefully you can go between these worlds of PD processing and JUCE without much issue, and you can learn some things, like cool things in PD that you want to make into a plugin, and you could test it out in processing, and then once you're ready to actually implement it, it should be the same, more or less the same code, and work the same way, without without having to relearn a whole new DSP system. Like you wouldn't have to do it from scratch. All right, well, thanks for watching, and I will see you next time.